guys about a game that I think you're going to find interesting. It's called the chaos game. And here's how it works. We have these 3 points up here in the shape of a triangle. And we have this 4th point right here in the middle. And that point's special because that point's going to be moving around. And the way it moves around is with this random picker. So that picker is going to pick a random corner. It's going to pick the green, the red, or the blue corner. And we're just going to jump halfway to the corner we pick. So for example, it just picked red. So now we're going to jump halfway to the red corner, just like that. I'll do it a few more times so you can get comfortable with it. Again, it says blue, so we're going to jump halfway to the blue corner. Again, picker says green, so we go halfway to the green corner. And last time, green again, so we go halfway to the green corner. So that's how this game works. We randomly pick a corner, and then we jump halfway to the corner we pick. So does anyone have any questions about how the game works? So one question you might want to ask is like, what's the point, right? We're jumping around, but like, who really cares? Why is this really a game? And what we want to do, the goal of this game, is really to just keep going over and over and over. And the question we want to ask is what happens to these points after we jump around 100 times or 1,000 times? Because you can see, I kept track of our history. I kept track of where we landed before. So now I want to ask you, what do you guys think is going to happen if we do this 100 times or 1,000 times? What do you think is going to happen to those points? Any ideas? Yeah, what do you think?
Will they kind of combine the different sections or patterns and where it lands?
Yeah, so that's a really good idea. Let's see what happens. So I programmed my computer to do this, so we didn't have to keep clicking through it. And here it is after 10 moves. So after 10 moves, it's still looking pretty random, I think. But here it is after 100 moves. And you can see there's kind of a pattern that's showing up. There's a lot of white space over here and here and here. So it looks like there might be a pattern that's showing up. And there it is after 1,000 moves. And here it is after 10,000 moves, if you make the dot size even smaller. And what comes out is this thing called the Sierpinski triangle. So it's really weird, right? Because we have all this randomness, yet we end up with this shape that has so much pattern and structure and order to it. So what I want to talk to you about in this talk is how this is possible. I want to give you some intuition for how this might be going on. So the goal is really to show you that in the face of randomness, we can actually have a lot of order and have patterns emerge. So let's go ahead and start getting some intuition for what's happening. I think a good place to start is to just try and track our moves, to see if we can find any patterns showing up in how we're moving. So if you remember, we started out right here in the middle, in that big triangle. And I want you guys to see if you can find any patterns in the triangles that we're visiting. So we started out there, and next we moved to this triangle. Then we moved there. Then we moved there. And I'll do it one more time, and I want you guys to see if you can find any pattern, maybe in the size of the triangles we're visiting. There, there, and there. So what do you guys see?
I guess smaller.
Yeah, exactly. So every single time, we're moving into a smaller triangle. And so now you might ask, okay, well, why does that matter? Why does that make this Sierpinski triangle? And here's the reason. So imagine we're starting out in this big triangle, and next we're moving into a smaller triangle, right? We're always moving into a smaller triangle. So that means we're never going to go back into this big triangle ever again. So there's no way it can get filled up. It's going to stay with at most one dot in it. And the same thing here. Once we leave a triangle of this size, we're never going to go back to a triangle of that size ever again. So there's no way that those are ever going to get filled up. So it's really this idea of constrained randomness. That's what I like to call it. It's random in the sense that we're always moving to a random corner, but it's not totally random because we're always moving into a smaller triangle. There's actually a pattern inside of that randomness. So now you might ask, okay, we have all these triangles, but why is this black space here? Why is that stuff there? And the reason that's there is just because of our dot size. So we keep moving into a smaller triangle, and eventually our triangle gets so small that our dot just covers it up completely. And you can see it's sort of starting to happen right there. So eventually we get into a triangle that's so small that our dot covers it up and we can't see it anymore. So if we make our dot size smaller, you can see that more of the triangles start to show up. So here it is with bigger dot size, and there it is with the smaller ones. We see more of these triangles. So that's kind of the intuition for what's happening. The intuition is that we've constrained randomness, that it's not totally random, there's actually a pattern inside of that randomness. And one thing I really love about this Sierpinski triangle is that we see the same sort of shape show up at different scales. So you can see that over here, we have the same Sierpinski triangle show up. And the same thing over here, and over here, and over here. We see the same thing show up again and again at different sizes. And in fact, we can keep zooming in forever if we have an infinitely small dot size. And the same thing shows up over and over and over. It's kind of fun to watch this, but I'm going to stop it. This is called a fractal. A fractal is when you see the same pattern or shape show up at a whole bunch of different sizes. And that's one reason why I think this chaos game is so important, because fractals show up all over the place. Some really important fractals are actually inside of us. So our lungs are fractals and our blood vessels are fractals. And you can see that the same sort of pattern that's happening over here at a large scale is also happening over there when we zoom in at a smaller scale. These things kind of look the same. And the fact that this pattern is happening at different sizes is what's making this thing a fractal. And fractals aren't limited just to inside of our body. They actually show up all over the place. Things like trees and rivers and mountains, those things are all fractals. You can imagine, like, if this were blue instead of red, it kind of looks like a river if you zoom out from an aerial view. And if you turn it on its side, it kind of also looks like a tree. So these fractals show up all over the place in nature. And it kind of got me thinking, is our universe sort of just playing the chaos game? Do we just have particles randomly moving around that are constrained by the laws of physics? There's actually a whole field of science that's called fractal cosmology, which believes that the universe itself is a fractal. Did you ever think it's kind of weird how an atom, which has a nucleus and electrons spinning around it, looks a whole lot like a solar system with a sun and planets orbiting around the sun? So fractals seem to show up all over the place, and I think studying the math of this chaos game seems to be really important. And I want to leave you with this final question, which is that with the chaos game, as I presented it before, we have 3 points. But what happens if we have 4 points instead, or if we have 5 points? What would end up happening in that case? What shapes would show up? And if you're interested, or if I have some time left, I have like 30 seconds, I can show you guys quickly. So here it is, the chaos game as we had it with 3 corners. With 4 corners, it turns out that it's just random. It looks like white noise. But with 5 corners and 6 corners, again, we see these really interesting patterns show up. And these shapes are actually fractals in themselves. So each of these petals, again, is sort of this same larger shape at a smaller size. And you can keep zooming in and the same shapes show up over and over and over. So that's all I have now, but I'm happy to take questions if anyone has.